Evolution is the interplay of genes and ideas in a vast interconnected network that drives human survival through the integration of cultural innovations with genetic adaptations. At its core, our evolutionary journey is a continuous exchange between biological traits and learned behaviors. By applying evolutionary game theory, we can begin to understand these strategic interactions where cooperation and competition shape adaptive strategies. Consider the discovery of fire. Fire was not simply a tool for warmth and light, it redefined human nutrition and survival. When our ancestors learned to cook food, they unlocked calories hidden in raw ingredients. Cooking breaks down complex molecules, making nutrients easy to digest and more accessible. Research by Ram in his book Catching Fire from 2009 shows that cooking can significantly increase the net energy available from food. This extra energy was crucial for brain development and allowed our ancestors to support larger and more complex brains. In contrast, many animals such as chimpanzees spent a large part of their day chewing raw food. Field studies by Prutz and Linshaw from 2010 indicate that chimpanzees can spend up to 6 hours daily on mastication, a process necessary to break down fibrous plant materials. This extended chewing period limits their overall energy efficiency compared to the more streamlined process of digesting cooked food. The human shift to cooking reduced the time and energy spent on digestion, freeing resources for brain growth and other adaptive pursuits. This cultural practice of cooking initiated a powerful feedback loop between our phenotype and our environment. The energy surplus from a cooked diet supported the growth of larger brains and fostered the emergence of sophisticated social behaviors. As our ancestors embraced fire, they set off a cascade of genetic adaptations that reinforced the benefits of cooking. In evolutionary game theory terms, cooking emerged as a winning strategy that reshaped the fitness landscape. The innovation of clothing offers another vivid example of how cultural practices and genetic evolution interact. Early humans venturing into colder climates developed garments to shield themselves from harsh weather. This cultural breakthrough allowed them to inhabit new regions, reducing environmental stress and paving the way for further genetic adaptations. Anthropological research such as the work of Jablonski on skin from 2013 supports the idea that clothing influenced our evolution, even affecting traits such as skin pigmentation. Clothing in this sense acts as an extended phenotype that shapes our survival and evolutionary trajectory. Domestication of animals represents yet another dynamic instance of coevolution. Humans forge mutually beneficial relationships with species like dogs, cattle, and sheep. In these partnerships, humans gained reliable allies for hunting, protection, and companionship, while animals received a steady supply of food and shelter. This reciprocal process of mutual selection is well documented by Zeder in his work on domestication from 2012 and illustrates how cultural practices can drive significant genetic changes over time. In natural ecosystems, plant and pollinator interactions further illustrate the power of coevolution. Flowers have evolved specific traits such as color, shape, and scent to attract targeted pollinators like bees, while these pollinators have in turn developed specialized features to harvest nectar efficiently. This reciprocal adaptation, a concept rooted in Darwin and refined by modern ecologists, fine-tunes the phenotypes of both plants and pollinators and sustains balanced ecological networks. Modern technology now accelerates these age-old evolutionary processes. Advances in biotechnology and artificial intelligence are rapidly altering the environment in which natural selection operates. Max Tegmark, in his work Life 3.0 from 2017, envisions a future where intelligent systems become an integral part of our evolutionary narrative. Imagine a world where smart machines not only serve our needs but also interact with our genetic and cultural frameworks, potentially speeding up the feedback loops that have driven human evolution for millennia. This integration could lead to rapid shifts in both our genetic makeup and our cultural practices. Today, our reliance on cooking is a cornerstone of human adaptation. The practice of preparing food has become so central that it reshapes our very biology. By reducing the time and effort needed to extract calories from food, cooking has allowed humans to invest energy in developing larger brains and more complex social systems. This efficiency is starkly different from other species like chimpanzees, whose lengthy chewing routines limit their energy availability. Every cultural breakthrough, from mastering fire and cooking food to developing clothing and domesticating animals, reinforces the intricate dance between our genes and our ideas. Each innovation alters the fitness landscape by freeing up time and energy, enabling intellectual and social advancements that further shape our evolutionary path. As we stand on the brink of another transformative era, the coevolution of genetic and mimetic elements continues to redefine what it means to be human. Understanding these processes through the lens of evolutionary game theory reveals the deeply strategic nature of our adaptations. Every innovation, every shift in behavior creates new opportunities and challenges that alter the environment in which natural selection operates. The interconnected feedback between culture and biology is a powerful engine of evolution that has propelled our species from primitive beginnings to the forefront of innovation and intelligence. As we integrate cutting-edge technology with age-old cultural practices, we enter a new chapter of evolution where the boundaries between nature and nurture blur. The ongoing dialogue between genetic and mimetic evolution is not just an academic concept, it is a living dynamic process that shapes our past, present, and future. By studying these feedback loops, we can better navigate a rapidly changing world and anticipate the challenges and opportunities that lie ahead. In sum, our evolutionary journey is defined by the strategic interplay of cultural practices and genetic adaptations. From the discovery of fire and the art of cooking to the innovation of clothing, animal domestication, and the promise of advanced technologies, each step has been a move in the grand game of evolution. This full system coevolution underscores the dynamic and adaptive nature of life, reminding us that every cultural innovation has the power to shape up biology and every genetic shift opens the door to new cultural possibilities.